Chapter 2 Emerging JavaScript. Since its release in 1995, JavaScript has gone through many changes. At first, it made adding interactive elements to web pages much simpler. Then it got more robust with HTML and Ajax. Now, with Node.js, JavaScript has become a language that is used to build full-stack applications. The committee that is and has been in charge of SHEP herding the changes to JavaScript is the European Computer Manufacturers Association. SHENECMA. Changes to the language are community-driven. They originate from proposals that community members write. Anyone can submit a proposal to the ECMA committee. The responsibility of the ECMA committee is to manage and prioritize these proposals in order to decide what is included in each spec. Proposals are taken through clearly defined stages, from stage 0, which represents the newest proposals, up through stage 4, which represents the finished proposals. The most recent major update to the specification was approved in June 20151 and is called by many names ECMA Script 6, S6, S2015, and S6 Harmony. Based on current plans, new specs will be released on a yearly cycle. The 2016 release was relatively small, but it already looks like S2017 will include quite a few useful features. We'll be using many of these new features in the book and will opt to use emerging JavaScript whenever possible. Many of these features are already supported by the newest browsers. We will also be covering how to convert your code from emerging JavaScript syntax to S5 syntax that will work today in almost all browsers. The CANAX compatibility table is a great place to stay informed about the latest JavaScript features and their varying degrees of support by browsers. In this chapter, we will show you all of the emerging JavaScript that we'll be using throughout the book. If you haven't made the switch to the latest syntax yet, now would be a good time to get started. If you are already comfortable with S.NextLang Huge features, skip to the next chapter. Declaring variables in S6 prior to S6, the only way to declare a variable was with the var keyword. We now have a few different options that provide improved functionality. Const. A constant is a variable that cannot be changed. Like other languages had done before it, JavaScript introduced constants with S6. Before constants, all we had were variables, and variables could be overwritten. Var pizza equals true pizza equals false console.log pizza // false. We cannot reset the value of a constant variable, and it will generate a console error. Figure 2-1 if we try to overwrite the value. Const pizza equals true pizza equals false. Figure 2-1. A. An attempt at overwriting a constant. Let JavaScript now has lexical variable scoping. In JavaScript, we create code blocks with curly braces. W. If functions, these curly braces block off the scope of variables. On the other hand, think about if /else statements. If you're coming from other languages, you might assume that these blocks would also block variable scope. This is not the case. If a variable is created inside of an if /else block, that variable is not scoped to the block. Var topic equals JavaScript. If topic. Var topic equals React. Console.log block. topic // block react. Console.log global, topic // global react. The topic variable inside the if block resets the value of topic. With the let keyword, we can scope a variable to any code block. Using let protects the value of the global variable. var topic equals JavaScript. If topic. Let topic equals react. Console.log block, topic // react. Console.log global, topic // JavaScript. The value of topic is not reset outside of the block. Another area where curly braces don't block off a variable's scope is in for loops. var div, container equals document.getElement viid container. For var I equals 0, I. Div equals document.createElement div. Div.onClick equals function. Alert this is box I. Container.append child div. In this loop, we create 5 divs to appear within a container. Each div is assigned a non-click handler that creates an alert box to display the index. Declaring I in the for loop creates a global variable named I, and then iterates it until its value reaches 5. When you click on any of these boxes, the alert says that I is equal to 5 for all divs, because the current value for the global I is 5 figure 2 to 2. Figure 2 to 2. I is equal to 5 for each box. Declaring the loop counter I with let instead of var does block off the scope of I. Now clicking on any box will display the value for I that was scoped to the loop iter. Figure 2 to 3. var div, container equals document.getElement viid container. For let I equals 0, I. Div equals document.createElement div. Div.onClick equals function. Alert this is box I. Container.append child div. Figure 2 to 3. T. Key scope of I is protected with let template strings. Template strings provide us with an alternative to string concatenation. T. They also allow us to insert variables into a string. Traditional string concatenation uses plus signs or commas to compose a string using variable values and strings. Console.log last name, first name, middle name. With a template, we can create one string and insert the variable values by surround. In them with console.log last name, first name, middle name. Any JavaScript that returns a value can be added to a template string between them. In a template string. Template strings on a whitespace, making it easier to draft up email templates, code examples, or anything else that contains whitespace. N. How you can have a string that spans multiple lines without breaking your code. Example 2 to 1 illustrates using tabs, line breaks, spaces, and variable names in an email template. Example 2 to 1. Template strings on a whitespace. Hello first name. Thanks for ordering quantity tickets to event. Other details. First name, middle name, last name. Quantity X price equals T price to event. You can pick your tickets up that will call 30 minutes before the show. T. Hanks. Ticket agent. Previously, using an HTML string directly in our JavaScript code was not so easy to do because we'd need to run it together on one line. N. Now that the whitespace is record. Recognized as text, you can insert formatted HTML that is easy to understand. Document.body.inner.html equals the HTML5 block. Article.title. Article.body. Copyright new date.get year the HTML5 block. Notice that we can include variables for the page title and article text as well. Default parameters languages including C and Python allow developers to declare default values for function arguments. Default parameters are included in the S6 spec, so in the event that a value is not provided for the argument, the default value will be used. For example, we can set up default strings. Function log activity name equals Shane McConkey, activity equals skiing. Console.log name loves activity. If no arguments are provided to the favorite activity function, it will run correctly using the default values. Default arguments can be any type, not just strings. Var default person equals name first Shane, last McConkey. Fav activity skiing. Function log activity equals default person. Console.log.name.first loves p.fav activity. Arrow functions are a useful new feature of S6. With arrow functions, you can see functions without using the function keyword. You also often do not have to use the return keyword. Example 2-2 shows the traditional function syntax. Example 2-2. As a traditional function. Var_lordify equals function first name. Return first name of Canterbury. Console.log_lordify Dale // Dale of Canterbury. Console.log_lordify Darrell // Darrell of Canterbury. With an arrow function, we can simplify the syntax tremendously. As shown in example 2-3. Example 2-3. As an arrow function. Var_lordify equals first name equals first name of Canterbury. Semicolons throughout this book. Semicolons are optional in JavaScript. Our philosophy is, why put in semicolons that aren't required? This book takes a minimal approach that excludes unnecessary syntax. With the arrow, we now have an entire function declaration on one line. The function keyword is removed. We also remove return because the arrow points to what should be returned. Another benefit is that if the function only takes one argument, we can remove the parentheses around the arguments. More than one argument should be surrounded by parentheses. // old var_lordify equals function first name, land. Return first name of land. // new var_lordify equals first name, land equals first name of land. Console.log_lordify Dale, Maryland // Dale of Maryland. Console.log_lordify Darrell. Culpeper // Darrell of Culpeper. We can keep this as a one-line function because there is only one statement that needs to be returned. More than one line needs to be surrounded with brackets. // old var_lordify equals function first name, land. If first name. Throw new error a first name is required to lordify. If land. Throw new error a lord must have a land. Return first name of land. // new var_lordify equals first name, land equals If first name. Throw new error a first name is required to Lordify. If land. Throw new error a lord must have a land. Return first name of land. Console.log Lordify Kelly, Sonoma // Kelly of Sonoma console.log Lordify Dave // JavaScript error. These if / else statements are surrounded with brackets but still benefit from the shorter syntax of the arrow function. Arrow functions do not block this. For example, this becomes something else in the setTimeout callback, not the to-who object. var to-who equals resorts Kirkwood, squall, alpine, heavenly, north star, print function delay equals 1000. Set_to_me_at function. Console.log this.resorts.join, delay. To-who.print / cannot read property join of undefined. This error is thrown because it's trying to use the .join method on what this is. In this case, it's the window object. Alternatively, we can use the arrow function syntax to protect the scope of this. var to-who equals resorts Kirkwood, squall, alpine, heavenly, north star, print function delay equals 1000. SetTimeout equals console.log this.resorts.join, delay. To-who.print / Kirkwood, squall, alpine, heavenly, north star. This works correctly and we can join the resorts with a comma. Be careful, though, that you're always keeping scope in mind. Arrow functions do not block off the scope of this. var to-who equals resorts Kirkwood, squall, alpine, heavenly, north star, print delay equals 1000 equals setTimeout equals console.log this.resorts.join, delay. To-who.print / cannot read property resorts of undefined. Changing the print function to an arrow function means that this is actually the window. To verify, let's change the console message to evaluate whether this is the window. var to-who equals resorts Kirkwood, squall, alpine, heavenly, north star, print delay equals 1000 equals setTimeout equals console.log this equals window, delay. To-who.print it evaluates as true. To fix this, we can use a regular function. var to-who equals resorts Kirkwood, squall, alpine, heavenly, north star, print function delay equals 1000. SetTimeout equals console.log this equals window, delay. To-who.print / false trans spelling S6 not all web graph